Okay, we're still working on the evaluation of exponential numbers. This follows lesson 2-3 if you're in the applied algebra curriculum. In 2-2 we talked about, or in the last video we talked about how these two scenarios yield two completely different answers, and we worked on this first example. In this video we're going to work on the second scenario where it's the opposite of 2 to the 5th power. This could also be written, and usually is written without the parenthesis at all. It's almost always written like that, and it usually is going to occur in an expression which you'll see in our later practice sets without any type of parenthesis, because that's meant to be a positive 2, or to be seen as a positive 2 raised to the 5th power. So this and this are exactly the same thing. They're communicating exactly the same thing. So this reads the opposite of 2 to the 5th power. So does this one, the opposite of 2 to the 5th power. The way this works is now the negative is not raised to the power. In order for the negative to be raised to the power, it has to be communicated that way using a parenthesis. No parenthesis here, or if the parenthesis is not around the negative, then the 5 is only acting on the 2. So I'm going to put the negative out here, the opposite of, and then I'm going to raise 2 to the 5th power. 2, 1, 2, 3, 4, 5 times. Again, that's what 2 to the 5th power means. We already know from past examples that 2 to the 5th power is 32. Now we bring the negative back in, which is the opposite of 2 to the 5th power. The opposite of 32, or 2 to the 5th power, is negative 32. It's that simple. But you see the difference between this one and especially this one where the negative is inside. When we had the negative inside in the prior examples, we multiplied the negative. The negative outside, we do not multiply the negative anymore. So in this case, it should always be negative, but let's test that. The thing about math is we can always test our theory, so let's just change this to a 4. Make a negative 2 to the positive 4th power, because in the last example, when it was in parentheses and we raised it to an even power, we ended up with a positive number. That shouldn't happen here. Let's just make sure. The opposite of 2 to the 4th power, 2 times 2 times 2 times 2, 2 4 times, and that's 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is 16 now, and it's the opposite of that, so still negative. So when it's written in this format, you're always going to end up with a negative number, or negative result. Just to compare two more really quickly, let's look at negative 3 to the 3rd power and negative 3 to the 4th power. Chose these because we already know these calculations, and you can do this. 3 times 3 is 9, times 3 is 27. To the 4th power, 3 times 3 is 9, times 3 is 27, times 3 is 81. Eventually, when you work with these numbers enough, you start to memorize them. It's not necessary that you have them memorized at this point in time, because you can always figure it out. So negative 3 to the 3rd power is equal to the opposite of 3 to the 3rd power, or the opposite of 3 times 3 times 3, which is 27. So it's negative 27. Negative 3 to the 4th power is equal to the opposite of 3 multiplied together 4 times. We just went through that. It's 81. So negative 27, negative 81. And of course, the numbers can get much bigger. So I think there are some bigger numbers in the practice sets for these lessons. Practice using your calculator to make sure you're entering it correctly. Because one common misconception or mistake maker in math is when we use a calculator incorrectly.